Hello everyone. Okay, in this lecture we're going to learn about binary arithmetic. So it's operation involving addition, subtraction, multiplication and division for binary numbers. Okay, so without further ado, let we continue with the first operation, which is binary addition. Let's consider this number. Let's consider this table A plus B. Okay, for example, now we consider this is 0 plus 0, 0 plus 1, 1 plus 0 and 1 plus 1. Okay, for example, this one B is 0 and A is 0 in binary number system. Okay, in addition we will have two results of the addition, which is carry and the sum. Okay, now let me consider 0 plus 0. What is the result of the summation? 0, and we have nothing to carry, so another 0. How about 0 plus 1? The summation is 1 and the carry is 0. Nothing to carry, we only have summation of 1. How about 1 plus 0? The result is also 1 with the carry of 0. How about 1 plus 1? So the result is we carry 1 and the result is 0 here. Okay, so this is example for the binary addition. Okay, the carry is handled the same way we handle carries in decimal. Okay, now we go for example. Add 6 to 3 in 4-bit binary arithmetic. So first, what is your 6 numbers in binary? Okay, we try this first. Okay, it will be useful if you're able to memorize, but with the help of calculators you can convert this rather easily. Okay, so I just want to teach about how if you want to use calculators. Okay, so you can mod for the base number 3, then this is decimal. So what is number 6? What is the equivalent binary? Is 110. But remember the question say add 6 to 3 in 4-bit binary arithmetic, so you plus 0 here, so it's 4-bit. Okay, how about the 3 decimal base 10 in binary? Is 11, so you add another 0 here to complete the 4-bit binary system. I advise you guys not to really use calculator, but if you really struggles or you have difficulty, calculator is there to help. Okay, so this one is actually it's not that difficult. Let's say 6 10, right? So you have 2 0, the weight 2 1 2 2 2 3 in 4-bit binary system. Okay, so how you get the combination of 6 base 10? Okay, first you need to know the value first. Here is 1, here is 2, 2 to the power of 2 is 4, and 2 to the power of 3 is 8. Okay, which actually result in 6. You can clearly know it's 4 plus 2, right? So that's why 0, 1, 1, 0 base 2 is equivalent to 6 base 10. Okay, now let me continue. Okay, addition. 0 plus 1, the summation is 1, but you have nothing to carry. So proceed. 1 plus 1. Okay, then is here, you refer here, you carry 1, then you carry 1, so 1 plus 1, 0. So you carry 1 to here. Okay, then you have 1 plus 1, then you have 0. You carry another 1 to here. Okay, then obviously here is 1 plus 0. You get sum of 1, carry of 0, so you have this. Base of 2. Okay, so here, you know, in your normal number, 6 plus 3 is actually 9. Okay, so this is your answer, which is 1001 base 2. Okay, this is considered your organ. This is considered your addend, the number that to be added, and this is the result. Okay, while this is your carries. Okay, we start the operation from the least significant bit to the most significant bit. Okay, now we go to the next example, the next operation, which is the binary subtraction. Okay, in binary subtraction, for example, if you have number a minus b, okay, let's consider 0 minus 0, 0 minus 1, 1 minus 0, and 1 minus 1. Okay, in addition, you have carry and sum, the result as the result of your addition. How about subtraction? You have actually two possible results when you subtraction. Either you borrow and you have the results of difference. Okay, now let's consider the first case. 0 minus 0, so you have nothing to borrow, and the difference is 0. How about 0 minus 1? So it is not enough, right? So you have to borrow 1. You have to borrow 1 in order for you to subtract with 1. Okay, so when you borrow 1, then you only have then you can add, then you can subtract with 1, right? So now you have the difference of 1. The next is 1 minus 0. You have nothing to borrow. Then here you have your difference of 1. Similar with this one, you have difference of 1. Here you also have difference of 1. But here, because 1 minus 0, 1 is greater and this one is smaller, so that's why we don't have to borrow, but this one we have to borrow, okay? Because 0 minus by 1 and subtract with 1 is not enough. The next number is that 1 subtract by 1. 1 subtract by 1, we have nothing to borrow. And what is the difference? The difference is 0. Now we go to the example. Subtract 2 from 5 in 4-bit binary arithmetic. Okay. When it mentioned the word subtract 2 from 5, okay, subtract 2 from 5, first you need to know this actually 5 will be subtract with 2, okay? And this is decimal numbers. If they didn't mention what is the base, so it is a base 10, okay? So 5 to be subtracted with 2 of the base 10 numbers, okay? In addition, you have carries, odd, hidden, and sum, but in subtraction, you will have borrows, minuend, subtrahend, and difference. Okay, now we want to know what is the equivalent number. Remember, it is 4-bit. Okay. First, you can use your calculator. I mean, if you struggle to know that, you can use calculator. But it's always the best that if you're able to somehow memorize and you don't need to depend on calculator so much. Okay. So, what is 5 base 10 in binary number? We know it is 1, 0, 1. It is enough to be in 4-bit binary arithmetic? No. So you add another 0. How about 2 base 10? So you know it is 1, 0. But is it enough to be in 4-bit binary arithmetic? No. You add another 0. 2 0. So that it becomes 4. Okay, now you can do the subtraction. Okay. So 1 minus 0, you get difference of 1, borrow 0. So you have 1 minus 0, it is 1. How about 0 minus 1? It is not enough, right? So you have to borrow another one. Okay? You have to borrow 1. So now 1 0 minus 1, then you have what? Then you have 1. 0 minus 0, so you have 0. And 0 minus 0, then you have 0. Okay? So your result of subtract 2 from 5 in 4-bit binary arithmetic is 0 0 1 1. base of 2, okay, which is equivalent to 3 of base 10, okay.